For number 27, you're going to want to set up a ratio. So it doesn't matter which way you do it, but I usually like to put X on the top. And let's just say we have the 3 cups of water on the bottom, and that's proportionate to a 1/3 cup of oats with 2 cups of water. Pardon me. So as long as you are comparing like to like, you're going to be okay. So this is my oats for this side, and this is my oats for here. This is the amount of water for these oats, and this is the amount of water for these oats. We could also do it X over, let's see, X is to 1/3 as 3 is to 2. You could also do it this way. So this side is the oats, and this side is the water, and these are proportionate. So you've got 3 cups of water to X amount of oats, and 2 cups of water to 1/3 oats. What you don't want to do is crisscross it like this. So you've got your 2 cups of water and an unknown amount of oats equals 3 1/3. You don't want to crisscross it like this. So just make sure that your proportions are equivalent, I guess. So you're comparing the amount of oats in one recipe to the amount of oats in the other recipe here, and the amount of water in the first recipe to the amount of water in the second recipe here. And then in the first situation, you're comparing the whole recipe amounts to the other recipe amounts. So as long as you keep them together, it's going to work out just fine. And then let's go ahead and do this one. So I picked this one. That's going to give us 2x equals 1, or x equals 1/2. So we're going to use 1/2 of a cup of oats with 3 cups of water. All right, the next question was 52. So this is saying to graph the equation by plotting the y-intercept and then plotting a second point by making use of the slope. So it's kind of giving you 2 keywords here, intercept and slope. So that should tell you put it in slope-intercept form. So what we want to do is take this and isolate the y. So let's add 4 to both sides. That's going to give us 2y equals 3x plus 4. And then we'll divide both sides by 2. So it's going to give us y equals 3/2 x plus 2. So here is our intercept, and this is our slope. So let's graph out. Our intercept is at 2. So let's go ahead and put a point here. And then we want to go up 3 and over 2. So 1, 2, 3, 4, 5, 6. So we're going to go up 3. 1, 2, 3. Oh, I didn't quite leave enough room. And over 2. So our next point is going to be right there. And then we can go ahead and graph it that way. The next question was 54. Determine the equation of the graph. So once again, we can use the slope-intercepted form in reverse now. So our intercept is what? We've got a +1 intercept. So this is going to equal y equals mx plus 1. And now we want to look at the slope. So what are we doing? We're going down. So we're going down 1 and over 1. So it's going to be y equals -x plus 1. The next question was 57. So solve the system by graphically. So I always think it's easiest to graph this when it's in slope-intercept form, for the exact reason you just saw in the last question. As long as we have a slope-intercept form, we can easily find our intercept and then just count our slope, our distance, our rate of change from there. So let's turn these both into slope-intercept form. So we've got 2y equals negative x plus 5. And then we're going to divide both sides by 2. It's going to give us y equals negative 1/2 x plus 5 halves. And then let's do the next one. We've got 4y minus 2x equals negative 2x plus 4. And then we're going to divide both sides by 4. It's going to give us y equals negative 1/2 x plus 1. Pardon me. What I want you to do, we don't even have to graph anything right now. I don't know if you see it or not, but these both have the same slope and different intercepts. So these are going to be parallel lines. It doesn't matter which, we know that it's inconsistent because they are parallel, they're never going to meet anywhere. So in this particular one, you would just say that it's inconsistent. And let's see, what's the next one? 59. By substitution. So now we can take y equals 2x minus 3 and plug that in for here, and then solve for x. So we've got x minus 2 times 2x minus 3 equals 9. Let's go ahead and distribute the negative 2 here. Let's distribute that through. So we've got negative 4x plus 6 equals 9. And then let's combine our terms. We've got an x, one positive x minus 4x. That's going to leave us with negative 3x equals 3. And I'm going to divide by negative 3. So x equals negative 1. State whether the system is inconsistent or dependent. So let's plug our negative 1 back in. And that's going to give us negative 1 minus 2y equals 9 plus 1 so y equals negative 5. So we've got 1 point it's suggesting at negative 1, 5. So we want to know, is this true for the other equation? So does negative 5 equal 2 times negative 1 minus 3? Oh, I double equaled, sorry. So negative 2 minus 3, so that's true. And then let's plug it back into the first equation as well. So we've got, does negative 1 minus 2 times negative 5 equal 9? And so that's going to give us a negative 1 here and a positive 10 here. So yes, so it is a solution. Here is the ordered pair is going to be right here, negative 1, 5. Negative 1, negative 5. And some of the other ones that you didn't answer were 60 and 61. So I'm going to go ahead and stop there because these are the same exact way. So you'll just put this, substitute it. So set this either equation equal to x or to y, and then substitute that back into your original equation to find that variable. Like we did here, we found y, and then plug y in to find your x. Oh, sorry, no, I said it backwards. We found our x of negative 1, and then we plugged that into the equation to find out what our y was, and then we checked them to see if that made both of these true. So do that for 60 and 61, and I'm going to stop this video here and then make another one for the remaining questions.